All right, thank you, Paul. Paul has just volunteered for taking minutes. Yay.
That's good. All right, so I think my clock is now half hour past midnight, so we are about to start. So it's 9:30 UTC. So this is Ipsecme Maintenance and Extensions Working Group. I think it was supposed to be minor extensions. Did I misspell that one? All right, anyway. So this is the IETF meeting. So we have a note well. You have probably seen that before and noted it well. So we need some minute takers. We don't need not Jabber scribe because we can actually read the Jabber in the chat here. So I don't think we actually need that one. But Paul has already agreed to take the minutes. So that's actually nice. There's already template made in the Etherpad. So use that and if anybody else while Paul was talking, for example, you can make some notes for that or help him to add some things. And if you ask something, you can also go and type your question there to get it correctly, written down. All right, so I don't think we have any other administrator tasks. So our agenda is quite tight because we had on 1 hour. So I don't think we actually want to go too much detail in here. So we have let's start with the status report of the, documents. So we have 2 documents waiting for chair review and write up. So the version 2 intermediate and Ipsecme IPTFS. I was actually doing the chair review for IPTFS and I had some questions, but then I ran out of some other meetings and so on. I couldn't actually come back to them. So I tried to get them, resolved. Okay, let's go ahead for Christian.
Hear me?
Yes, we can hear you.
Okay, great. Yeah, so I just wanted to. We started that thread on the list about a month back, hoping to get some comments from you on that. But it's I do have comments from off list. The thing I did about a month back, we published a new version that took some of your comments on the reordering. Yeah. I don't know if we covered all of your comments, but we think we covered the gist of the gist. And it's added about a paragraph that talked about reordering.
I'm sorry that I haven't been able to really, because in last month I have been having 2 weeks of IEEE meeting and 1 week of moving and 2 weeks of sailing in one last month.
Yeah. So I guess the only thing that we'd ask is that if there are any more changes to make, if we could work together to quickly turn those around, because we've been through a full cycle at post working group last call.
Yeah,
that'd be great.
Yeah, let's try to do that during this week. I will try to get it tomorrow or something like that. Try to go through when I have some time. Because there's only 6 hours of sessions in IETF, right. Because IEEE is a little bit annoying because they have 10 hour or 12 hours of sessions during the day.
Cool.
Yep, thank you.
Thanks.
Paul has some, I assume, for the historic stuff. No, we can't hear you. We can't hear you. Silence, silence.
Something has been doing funny things to my audio gain without me, so I have to check.
Does it work now?
Yes, now it works.
Okay. So for labeled IPsec, the same thing applies. There's no changes. I think last meeting we decided on working group last call would start, and I think should be moved up to your list for waiting for write-up chair review and be put on your to-do list for next week.
Did we do the working group last call for the labeled IPsec already? So I don't think we actually did that. I think it was waiting for this to the working group last call to start, wasn't it?
I think so. Yeah, that's what the data tracker told me when I looked at it yesterday.
All right, so I will start a working group last call for that because I think it's mostly ready for actually getting the working group last calls for to start with that one. All right, anything else? Okay, so then we have a couple of documents, like we have the Young and MIP documents. We are going through them, and then we have multiple key exchange, and that is also working. I think Valerie's probably had some comments on that. Go ahead, Valerie.
Hi, can you hear me?
Yes, we can hear you.
I just want to second Christian. Hope that you will find time to write Shepherd review for IQ2 Intermediate, because it's been waiting for you for chair review since previous IETF, and we have quite a lot of interoperable implementation, and I think the draft is quite ready for publishing.
All right, I will go through that one also.
Okay.
Or maybe I will
That would be also fun.
share the load.
Yeah. Okay. So I don't think we have anything for the this G-IC version 2, and I don't think there's lots of happening in the RFC 8229Bs. That's my understanding, but anyway. Okay, so let's go forward with this one. So then we start with the presentations. So the first one is the hybrid IC version 2 interoperable testing. So Valerie, if you can come up and start presenting. I just say that I will switch the slides when you say so.
Okay, so it's a very short informational message that we've had a hybrid IQ2 interoperability testing event. So next, please. It was on July the 1st. It was organized by SecureNet, and there were 3 participants: Strongs1, Elvis Plus, and Genoa. And we performed quite a lot of testing based on combination of IQ2 intermediate and IQ2 multiple key exchange. So, and we performed a real post-quantum crypto key exchange based also implementation used an libOQS library that contains quite a lot of post-quantum key exchange and signature implementations from the NIST third round list. So next, please. So the result was that Strongs1 and Elvis Plus performed up to 4 additional key exchanges with different algorithms like Kyber, Saber, Rodochem, Psych, and all works very well, except for a minor issue that the same additional key exchanges were selected that was prohibited by RFC. And with Genoa, initially there was some troubles with crashing when using libOQS, but later they fixed on the second day, and they also successfully performed interoperability testing, but slides are a bit dated, so it is not on the slides, but actually all 3 implementations were interoperable. So the next, please. So the results are that there are at least 3 independent implementations of this draft. So they are interoperable. We badly need common identifiers, and I'll request to assign code points for multiple key soon. And we also need temporary identifiers for post-quantum algorithm, because there are quite a lot of them. We use some private numbers that are on the right on the screen. And Genoa and LS Plus also are interested in testing Makelis, which doesn't fit in multiple key because it has a very large public keys. So it is based on beyond 64 card draft. And we're going to perform this test later, probably in September. So that's all. So the conclusion, the draft is quite, I mean multiple key exchange, is quite stable. So we have 3 interoperable implementations, and I think as a co-author, and I've discussed it with my co-authors, the draft is ready for working group last call.
All right. Was that all of it? I think that was the last slide, yes. Okay, so any questions on that? So I think we should probably start a working group last call on that, if you think it's ready.
It's Ludovic Perret. I have one question.
Go ahead.
Could you explain a little bit what was the experiment that you perform? So I saw there is SecureNet. So you have 3 different implementation of the Ipsecme post-quantum hybrid.
Yes.
And so you are 3 that implemented in some Ipsecme clients, including LibOQS. That's right. And after you test if it's more or less working. And so do you try to have some performance comparison or not at all?
Well, the goal of this event was to confirm that implementation are interoperable. So we didn't perform some performance testing. Well, from my experience as a user, it takes a bit longer. Well, but it's tolerable to establish IKSA with up to 4 post-quantum key exchange algorithms. But it takes about half a second or probably 1 second. But keep in mind that the implementation was on the different countries. So you can add some network delay to this, and so it's tolerable. It's a bit slower, but not that much that one can expect.
So yes, indeed, since it's hybrid things, you are doing more. So it's clear that it's slower. So it's good to know that it's not too slow. And so
Yes.
One point is that in the draft, so you consider the key exchange step, but not the authentication with certificates, with hybrid certificates.
That's true, because the draft that was tested, multiple key exchange, is focused on the post-quantum key exchange and not on post-quantum signature. So if you want to perform post-quantum signature, it's a different thing. It is not yet addressed in IETF.
Thank you.
Okay, Scott. Scott, do you have some question or something? You're in the queue.
Okay, am I listening now? Okay. Could you, a quick request? Could you please post the code points to the main list so we have a semi-permanent record of what you've actually used?
It's on the slides on previous. Well, it's probably not in the slide. Can you please move the slide back 1 slide? Yes.
Oh no, you're on the right slide.
Okay.
I'm
This
just
was the one that was to have it.
What's the question? Which algorithm did we test?
No. Could you please
Okay.
post the code points that you used to do the mailing list so that we have a permanent record of what
Okay.
you.
Okay.
So
Okay.
if somebody else
I'll
wants to
send-
test them, they can actually try to use the same private numbers.
Okay, sure.
Or yeah, okay. And I think there was one question in the chat about the 3 key exchange using the same algorithm. Was that intentional or failure in negotiation, or was it just failure in? I assume it was a bug in the code.
It was a bug, and actually, at least it was bug in my implementation. I've already fixed it, but I fixed it after the event take place. So probably the next interoperability event, we'll try to figure out whether this fix works.
All right.
So
Okay. I think that was that. Let's move to the next one, right on time. So the next one is 10 improvements for post-quantum equation 2. Daniel?
John is going to.
So, can you hear me?
Oh, no, wrong out of order. Sorry.
Can you hear me? Does it work? Great. So, I will talk about improvements for post-quantum IQ2. And the main point of issue we had with post-quantum IQ2 are intermediate exchanges. So, next, please. They are rather complex, especially the signing of them, and especially when used with fragmented messages or fragmented exchanges. And since the post-quantum key exchanges are rather large, they are most of the time fragmented. So the signing of them is quite complex. And that means always the risk of bugs and security critical bugs is always there. And we also have a high cost of maintenance and implementation. Furthermore, large post-quantum key exchanges like McAleese require data to be sent more than 2 megabytes in large parameter sets. And doing this before authentication leads to vulnerabilities against DOS attacks or DOS attacks. So we moved them in our implementation to the follow-up key exchange. How that looks, next please. We see here. So that is the state machine of IQ2 with all these drafts applied. And there we see we perform IQSA init, and thereafter we move on to intermediate exchanges, doing all the exchanges which do not require large amounts of data, so it might, like no McAleese, for example. Then we authenticate, then we immediately rekey the IQSA, and during the rekeying, we perform all the the key exchanges which require too much data to be sent during IQ intermediate. So we decided all the exchanges which require the beyond 64K draft to be applied have to be performed after authentication, and then they are performed during follow-up KE. That is the status quo, how we decided to implement the drafts as they are presented right now. Next, please. The first thing we would propose is to remove the intermediate exchanges for this context, because we have to have this workflow anyway, where we conduct additional exchanges after authentication during the follow-up key. And since this has an inherent risk for an attacker being able to break the initial exchange during IQSA init live, because they would then be able to recalculate the message authentication code, which is the anchor for security after authentication. We propose to add quite simple hybrid key exchanges like a ECDH and Psych, for example, something that fits into IQSA init. And then it is already secure on its own. And for someone needing a high level of security for a long time, so like, I don't know, 10 years or more, there is the possibility to have additional key exchanges after authentication, which also, if maybe in 10 years someone has an efficient way of breaking Psych, for example, or Entru in a small parameter set, and ECDH, there's still the McAleese or Frodochem, whatever, which is also should be secure also then. So a record and harvest attack is impossible. And the second exchange, the second change we would introduce is related to the state machine being not cleared in this state, because after ICAuth, we cannot rely on the essays being created and successfully established. So next, please. We propose to introduce an additional exchange, which is rather similar to ICAuth, but it explicitly says that the SAs are not yet established, and we require further key exchanges to be conducted. Otherwise, the handshake has to be aborted. And also, we have the possibility to introduce another hash of the public key from the follow-up exchanges, which is then also signed. So we do have an additional anchor for security also for the exchanges, key exchanges after the alternative auth. And yeah, then we have a more clear state machine or clearer state machine, which is easy to maintain. Next, please. So the benefits of these changes are we are rather for the use case of post-quantum key exchanges, we are independent of the complex intermediate exchanges. We we introduced the large post-quantum key exchanges, but DRS protected because they're after authentication. It is a more cleaner state machine because if we introduce them after the classical ICAuth, ICAuth doesn't mean the key handshake has finished. And in general, you have a new place for exchanging handshake data after establishing an authenticated channel due to the new exchange type, which might also be which might also make the introduction of post-quantum signatures easier, but that is another point. So that's it. Thanks a lot. So I think we have some questions.
Yeah, Valerie, very short comments. I think we need to take most of these to the list.
Well, actually, we discussed a little bit with Daniel already his proposal, and I think that there are a few things that I don't like about it. First, like intermediate is not used only for key exchange. It is also it may be useful, and I suspect it will be useful for other things too. And so if this proposal completely drops intermediate, I think it's not a good thing. Then I don't think that this proposal makes state machine simpler than it is. I think it makes it more complex. And the new authentication exchange, I think it's a new exchange. It's not ICAuth. It's like alternative auth. It's another exchange which must be implemented with. It is not clear for me right now what this exchange should contain until probably a draft will be written on something more detailed explanation. So it's difficult to make a conclusion whether it is more simple or more complex. From my understanding, it is more complex than intermediate. And intermediate has its own problems. It's a bit unusual, and DOS attacks concern is very serious, and I think it must be addressed. And but otherwise, I don't think this proposal is worth to drop intermediate and replace it with this proposal.
Okay, so I think we need to take to the list because otherwise it's going to take too long. And I agree that there is things that we probably need to solve in this. But I would like to send you to send a description of the problem and the solution to the list, or actually make a draft, and then we can start continue discussing. Okay, thank you. So the next is then the IPTFS and Young and SNMP drafts. Christian.
Actually, it's done.
Okay.
That I'm going to present it. Okay, next chart. So no changes. We've submitted the draft. It's basically it's the management for the IPsec, so for the IPTFS, and the only difference is the base file, the base Yang that we augmented for this is now an RFC. Next chart. And so the tree, this was presented before. So these are the management objects for IPTFS and the counters that we have for the IPTFS. Okay, next chart. So basically there's two documents because one is MIB and one is SNMP, and they're basically in the same state. So if you go to the next chart, we use the Yang to produce SNMP objects that could be were the same as the Yang, and so it's basically one model that and there's two views. There's the Yang view, and then there's the SNMP MIB view. That's so you can read it. And we talked about this before. That's because some people still would like to be able to read this with SNMP. And just for example, the next chart. So here are the objects in the MIB that correspond to the one before. So the summary is that we think because the IPTFS draft is progressed, these two drafts are the management model and they're ready to go for workgroup last call. So any comments?
Okay, any comments on this? I just started a couple of last calls. We have now 3 working group last calls ongoing, so I would actually like to postpone these and concentrate on get IPTFS out and then getting the 3 last calls out, and then hopefully start this after we get the IPTFS forward, so we don't consume resources for these while we are actually trying to get the main core document out first. So
Okay.
that would mean probably last call in a month or so.
Okay, yeah, that'd be great.
All right. Anybody else have any comments?
I guess the only thing I'd say is having had another Yang document go through workgroup last call, to get the Yang doctors onto it would probably be a good step that we could start initiating.
Did we already have the Yang doctors looking at it?
Not that I'm aware of.
Okay, okay. So I think there were some issues, some questions about that earlier. Okay, it might be some other thing that. All right, so. Okay, any other comments? I guess not. So let's go forward. So the next one is the this equation 2 configuration for encrypted DNS. Valerie.
So this draft was already presented. I think it was presented a couple of times, but it has some significant changes from the last IETF. The design was greatly simplified, and it was aligned with the recent ADD work, in particular with IETF EDD DNR design. It's also leveraged SVCB as a way to transfer parameters for encrypted DNS servers. And the draft addressed comments raised by the working group in IETF 1.1.0. So its deployment section to appendix, it's a minor comment, and the major comment was to rely upon IQ2 to validate end-to-end certificate. So we introduced, instead of using PKI, we introduced a new attribute that conveys the hash of the DNS server certificate. So the next, please. So what is simplified design? Instead of having 6 attributes for 2 IP versions families and 3 protocols like DOT, DOH, and DOQ, we have only 2 attributes now for version 4 and IP version 4 and IP version 6. And all of the specifics of encrypted DNS server is conveyed in service parameters that has a format of SVCB. So the next, please. And a new attribute is introduced. Its attribute contains a hash of the encrypted DNS server certificate, and the hash is computed using a hash algorithm from the IQ2 hash algorithm registry. So there's no need for new registry. We use an existing one. And at the same time, we have algorithm agility. That's a good thing. And SHA-256 is mandatory to implement. So the next, please. So the client requests includes an DNS digest info attribute with a list of hash algorithm it supports, and server selects one of these algorithms, computes hash or use a pre-compute hash of the certificate, and includes in response a hash of the DNS server certificate, along with hash algorithm identifier. So the next, please. So this is the diagram that just illustrates what I've said. So next, please. So next steps, and we think that the draft is now in the good shape, and I think it is ready. It can be considered for adoption by this working group. So please consider adoption of this draft. Thank you.
Comments. I guess Paul has something.
Yeah, sorry, I have a question. So these digests, are these fields inside the server certificate, or are these like different cert payloads?
It's a digest of DNS server certificate that is transferred inside IKSA. So that the next slide, please. The next slide has a diagram. So you can see that the client requests the parameters of the encrypted DNS server, and the responder returns a hash of the DNS server certificate, which the client can further compare with the certificate that the DNS server is using. So this time, this way, client verifies that by authentication with responder, it verifies that the DNS server certificate is valid.
Okay, so I guess I'm a little confused. Is why wouldn't we almost just send an SVCB presentation format DNS record to the client and say, like, this is what we have, you figure out what you want to use? Why is there an additional authentication here? Because the IKE exchange itself is already authenticated. So why do we have to have a separate authentication in this step?
It is not authentication, because IKE authenticates security association between client and initiator and responder. And we need to also authenticate, not authenticate, but validate the DNS server certificate. The DNS server is a different entities and responder. And so we need to know that certificate that is used by DNS server is valid from responder by authentication.
So isn't that exactly what the SVCB record does with the information inside that record?
I'm not sure. I don't know. SVCB record, I think, can contain a lot of different information. And it's better ask for my answers. Because
so I think it includes things like pub key and other things, and sure, it's maybe not authenticated if you do it that way. Anyway, I'll take this on the list. I'll have another look at it because it's now changed quite a bit. So I'll have another look and clarify my questions.
Okay.
Yeah, I have one question because it seems to be here. Here you have a hash algorithm identifiers,
Yes.
Seems to indicate there's a list of them, but how do you actually, is there some kind of end marker, or is there actually a number of them? And is there multiple certificate tickets also if you have multiple hash algorithms?
Well, the client includes a list of algorithm identifiers it supports, but responder returns only a single algorithm identifier.
Only single answers. So this is actually 16 bit. So the hash algorithm identifier here is only always 16 bits, and you know there's only one certificate digest with known length. Okay, so it's just the graphics here is a little bit funny.
Yes, it is clarified in the draft.
Yeah.
So sorry, sorry it is not clear from the slides, but in the draft it's clear.
Yeah, all right. Okay, any other questions on this topic? Do Paul have still something more? No, he went away, run away. Okay, so I think that's it for this, and then we move to the next presentation, which is beyond 64 kilobytes, limit of IETF version 2 payloads. Valerie again.
Okay, so this presentation was also presented, I think, a couple IETF before, but we had some changes. So next, please. So what is motivation for the draft? We have IETF multiple key, and it addresses issues of using large keys for key exchange method, but it still has a limit on the key size that is limited by any IETF payload, that is 64 kilobytes. And most NIST candidates fit into this restriction, but there is one notable exception. It's a classic mechanism, and with the smallest key size of 255 kilobytes. And some national regulators, like BSI, recommend using classic mechanism. So, because it is very conservative, and some cryptographers think that it is most conservative, and that's why most trustable of all the candidates. And we also anticipate that post-quantum digital signature will be used in IETF2, and looking into the NIST third round candidates, at least two algorithms that are either candidates or alternative candidates have either signature size or public key size greater than 64 kilobytes. It's Rainbow and Picnic. So next, please. So the goals of the draft is to define a way of transferring some specific data blocks in IETF2 that grow beyond 64 kilobytes. And these specific data blocks are public key for key exchange methods, signatures, and certificates. And we want this mechanism to be backward compatible, and we want to address reliability. We want so the performance of Ipsecme traffic not suffer. And we want that this mechanism must be as simple as possible and reasonable, and introduced minimal change to IETF. So the next, please. And not goal to define a generic mechanism of transfer any payload greater than 64 kilobytes, because it requires to redesign IETF2 payload format, and I think that it's another goal. Next, please. So the approach is very simple. If some block of data doesn't fit into the single payload, just split it into the chunks less than 64 kilobytes and place it into the sequence of adjacent payloads of the same type. And the responder will concatenate all these chunks and receive a large block of data. So this approach works very well if there is only one payload of a given type in a message. So, for example, like key exchange payload and auth payload. And it's not true for serve payload, but it can be worked around. And another problem is that if this sequence of payload of each of which is less than 64 kilobytes is encrypted, so it is placed inside encrypted payload, so the encrypted payload will always be greater than 64 kilobytes. But we think that if we use IKE fragmentation, then the actual length of encrypted payload is never transferred. And so it doesn't matter. We can use a value of 0 to indicate it and just deduce it from the message length because it is always the last payload in the message. So the next, please. So it's an example. So we have IKC init, then IKE intermediate with payloads that are in blue. It's this payloads that are split into several payloads, a large blocks of data that are split into several payloads. For example, in this diagram, it is key exchange payloads, set payloads, and host payloads. So the next, please. So what are the changes from 0.0 version? IKE fragmentation is now mandatory for both UDP and TCP. It is because the TCP, with TCP, the message size is still limited, the IKE message size is still limited to 64 kilobytes because TCP length prefix is 16 bits length. So we have to use IKE fragmentation even with TCP. Then we introduce a so-called mixed transport mode. And the mixed transport mode is a way of avoid problems that IPsec traffic, ISP traffic have when it is encapsulated in TCP. So with this mode, IKE is using TCP. So it is started on UDP and then switched to TCP on the first IKE intermediate exchange. But child SA are still created so that they use either direct transport or UDP encapsulation. So with this mixed mode, we have a reliable transfer of very large data in IKE SA, but still don't have problems that with performance that are caused by using TCP transport for ESP. So it's an optional mode. It is negotiated by exchanging new notification IKE over TCP, and we think that for transferring large public keys, it's very useful condition. So we also added some clarification how to tweak length of encrypted payload, and actually that's all for the changes. So the next, please. And a very important aspect is DOS attacks. We have sections that discussed them a bit, and we cite RFC 1819. But we think that more discussion is needed in the draft because of the large data blocks. So the next, please. So anyway, there is some interest in using, at least in using Mac-Elise from interest from vendors. So we think that the draft is in the situation, in the state when it can be adopted. And so if the working group is saying that this work is worth to conduct, so we ask for adoption.
Okay, Paul?
Okay, just one comment now. Like, requiring TCP is a really heavy-handed change to the IKE protocol. Like, while the world is moving more towards UDP, we would be moving towards requiring TCP, which would be really scary and easily filtered, easily blocked. So I would be very not in favor of requiring TCP.
Well, actually, it is not required to use TCP. It is an optional an option because with UDP it's quite difficult to reliably transfer Mac-Elise public keys. Actually, I performed some experiments on the local network on the LAN, and even using UDP, it is manageable to exchange Mac-Elise public keys. At least I managed to do it. it usually takes about a couple of seconds and about a couple of 3 transmits of the 255 kilobytes message, but it works. But with TCP, it's much more reliable. So it's an optional, but we have to address reliability too.
Yeah, so I'd like to agree that you can get better reliability with UDP, like they get in quick, but you need the quick mechanism. Just can't just use the thing what we have in IKE is not nearly as robust as what they have in quick. I'd like to push back on the statement that it's a non-goal to make it a generic mechanism. I think you could, if you just made the length field bigger, like adopt some of those 7 reserved bits next to the length field and use that as an extra length field, I mean, you could get payloads that are 4 megabytes or 8 megabytes, depending on if you use the last one. And I think that would be a simpler thing than the way you do it with multiple similar payloads, one after the other.
That was an option too, and the last IETF I presented some ideas of a new payload format, but as far as I remember, that wasn't received very well. And actually, it's quite a lot change to the protocol. It's a larger change, more deeper change, because payload format is very inside the protocol, the code, and you have to also negotiate using new feature, backward compatibility. So, well, it's an option. So we can discuss it, but if there is an interest in the working group. But for now, we think that this approach, our approach is simpler. It's not ideal, and of course it's some protocol hack, but it's a simple hack.
It just seems to me that having a big certificate in one big payload is better than having one certificate in multiple cert payloads, but that's just me.
And actually, you can have 5 certificates in the same IKE message, and each of them would be fragmented in multiple pieces, and you have to somehow separate them. And of course, yeah, and if you think about that, understanding is that all the beyond 64 kilobyte packets are inside the encrypted payloads.
Yes.
Exactly. Which means that at the encrypted payload, you're proposing or handling it so that the length field of that is going to be 0, which means that all the old implementations are going to be barf at that point anyway, because they will actually check that. So after you get past that check that, okay, the encrypted payload length is 0, okay, then we can actually, go to the other part and say that, okay, now we just change the payload numbers to payload lengths to 32 bits or something like that. I don't know. But this is something that I think we should probably think about it when we are actually processing those. So you are proposing for this for the working group adoption, and I think this was in our charter, so we can probably, was it actually, try to remember, did we add this already to the charter? But it goes anyway. It goes with the post-quantum crypto stuff anyway, because we need that for it anyway. So I think we can actually still adopt this as a working group document. So I will think we are good. For the last 2, actually, I think we're probably going to be making adoption calls quite soon.
Okay.
All right, so then we go to the next presentation, right on time, I think, 1 minute early. So go ahead.
Okay. Hello, everyone. My name is Wei Pan, and I'd like to present the IKE version 2 optional SA and TS payloads in child exchange. And this draft was previously presented at, was first presented at IETF 105. And next slide, please. Currently, the draft is in version 07, and thanks a lot for the comments and feedbacks and suggestions. The whole solution now is much simpler, and text is more readable. For now, the whole optimization solution comprises of 3 steps. First is negotiation of support. And after the negotiation, the initiator and the responder can do the optimization, that is, omitted the SA payloads at Rikin IK essays and omitted the SA and TS payloads at Rikin child essays. For now, there is no more consideration for the situation of configuration change. These considerations will give more complexity previously. So according to the RFC 7296, the configuration change isn't allowed for Rikin. So if you change the configuration, then you need to create the new IK essays and the child essays. So the new notify message type notifications, there are only 2 notifications are needed now, and the previous was 3. And the next pictures shows the comparison between the previous version and the current version. You can see that the right picture, the current version is much simpler. And also now we have new 2 co-authors, the Paul Waters and Mei Lin Chen, and welcome them. Next slide, please. This slide shows the steps, 3 steps of optimization, and the read parts are the new notifications are added, and you can see there is it's much simpler and reduce the packet size of the Rikin messages. Next slide, please. For now, about the draft, there the authors think there are some open questions. First, should the supported notify mean that peers may or should or must use this method? Must may be too strong, and we think should may be better. And second question is, alternatively, if the supporter notify could have a payload that signifies whether the old method is supported or not. We think this is not necessary, and it will increase the complexity. So we don't want to do that, but we also want to hear others' opinions. Third is about whether a child essay was negotiated with PFS. What should an optimized key do when there is no KE payload? Send the invalid KE payload. And we also want to hear from the colleagues. Next slide, please. And for now, we'd like about next steps. We'd like to ask for working group adoption, and we are welcome others to discuss and close the open questions. And we're also looking for implementations to do interop testing. That's it.
Okay, Valerie, you have some questions?
May I ask for a preview slide? So for the first question, I think that supported always mean may. It's my opinion, because it's negotiation of capability. And well, if you want to use it should, as should, then it is not supported, but something like always use. And For the third question, I have another question. What about the first child essay? Is it well, the first child essay is created when IKSA is created. So is it considered as negotiated with PFS or not? So it's just inherited PFS from the IKSA, the Diffie-Hellman parameter, Diffie-Hellman shared secret.
I think about the Riking IKSAs, the PFS are used because it contains the KE payloads, and about the child essay, it was optional. You can include the KE payload or not. Yes.
No, I understand all this thing. The question you have is when the child essay was negotiated with PFS. I'm asking, what about the very first child essay? Is it considered as negotiated with PFS or not, or without PFS? Because the first child essay, in fact, doesn't have its own PFS. It just inherits key material from IKSA. It's the first child essay that is created in IKOS. You exchange key exchange payload and IKSA need, and the resulting entropy is used for both child essay and IKSA.
Yeah, I think maybe Paul want to answer this question, or
We can hear you.
Okay. So in the traffic selectors for that child essay in IKOF, there is the Diffie-Hellman group as a transform. So you do signal that it is one with PFS.
Yes.
So you know it should come with PFS next time if you get a create child essay for it.
Okay, I understand. Okay, let's go into the mailing list with this question because we have.
All right, check out. So I don't think we actually also include that, but I think we actually are running out of time, and we probably have one more presentation from Paul. So I think we should take those questions to the list, and
Okay.
it might be much easier to understand there when we have a diagrams that people can actually read the graphs. Okay, Paul, you can stay there and go to your presentation.
Okay, so this is about our per CPU or per queue child essays. So hopefully you have read the draft, because I will definitely assume you've read it for the questions or the items. So next slide. So just a summary, the goal of the draft is to get like 40 to 100 gigabit per second wire speed IPsec using multiple CPU cores. Normally, that gets downgraded to 2 to 5 gigs because we have one tunnel with one counter and synchronization issues. And so what we're planning to do is having multiple child essays in parallel bound to CPUs or network queues that can independently push this traffic much faster. And we have reached like 40 to 60 gig speeds using this implemented in Linux. So next slide. So some changes since the last draft. We changed the name of the draft. We fixed it. We separated the notify. So it's like an info notify that could apply to either CPU or a quality of service. We separated them into 4 clear notifies. So one is QoS and QoS info. One is CPU and CPU info. We clarified the terms initial child essay because it's a little confusing when it's getting rekeyed. So we called that the fallback child essay. We also added the info notified to be always added if you want one of these additional child essays, just to make it easier to recognize it, because someone could start a traditional a traditional create child essay with no identifiers, meaning that it's just separate from this mechanism. So by adding the info, we know it's meant for this mechanism. We ran into a bunch of corner cases about the number of tunnels you want to negotiate. So instead of the minimum, we picked the maximum. So you basically pick the maximum of the two parties, obviously within like denial of service reasonability, and that gets you out of a lot of the corner cases that we saw. We attempted to clarify the QoS case, but I'll talk about that a little bit more. We added some operational considerations that we realized about, mostly about acquires, and if you don't have per CPU acquires. So next slide. So then this was the major issue. So the authors on this draft are actually not quality of service experts, and we see a bunch of issues with quality of service and how to do that. So first of all, there's no code, so we can't actually test any of this. Another question is, what do you do with QoS? Do you like negotiate all of the possible combination flows at first? And so do you start like 64 tunnels, or do you just say like, well, I only have really like, bulk and importance, so I only need 2, so I want to start 2 of them. Then there's the question of how does quality of service work with IPv4 and IPv6 flow labels if you combine a traffic selector with both v4 and v6 selectors? Like we just don't know. We're wondering if you reject a flow, if you need a new TS error about traffic selectors, or if you can reuse TS unavailable, or sorry, TS unacceptable. And then another big question is, can you even combine the per CPU one with the per QoS one, and how does it really look, and what would work? So we don't really know the answers to these questions, so we are kind of tempted to say, maybe if there's really QoS people, they should put all of this in their own draft and work on it and get these things done. And we would like to see maybe kick this out of our draft. So our draft focuses on the CPU/network queues that are available, because that's actually the code we're seeing, we're implemented, we know about. We just have too many questions about this. So that's one question for the working group. So next slide. There was some talk about what to return error code-wise, and I know that Valerie had suggested no additional assays, but we realized that there's one issue with that. If you have an ICSA with multiple child assays, and with some of them you want to do these multiple children, and with some of them you don't, then doing no additional assays might be confusing to say whether you mean no additional assays for this traffic selector set, or that it's still allowed to do other traffic selectors. So we think no additional assays is the wrong solution. So we think it should still either be TS unacceptable or maybe just a custom new code. And so there's a note here as well that we've worked on this for quite a few years, like I think going back to Prague a couple of years ago. And so we would really like to see if the working group is interested, because we really need to know whether we should merge this code into the Linux kernel and the IKE daemons, or whether we should give up on this and look at other ways. So that's an important point for us. And I think that's the last slide.
Yeah, I think so. So the question there is that I'm not sure if it actually, we don't have a chartered item for this, but I think it could be considered as a minor extension. So we should probably talk with an AD about this and one also. The previous one could be actually put into the compression stuff, but we have to think about it more. So I think we need to have a discussion with an AD and the authors and see if we need to do charter or something like that. But we are now running out of time, so we can't do that one now. But I please send a list to the email to the list and remind this and ask for added CC the ADs and our ADs are coming now in.
Right. No, I agree. We should talk about this offline. But I wanted to join the queue to say something unrelated, which was, since we were talking about post-quantum so much and hybrid techniques today, I wanted to point out that tomorrow at the SAG session, we're going to have a topic for how should the IETF be handling post-quantum stuff in general, which may be of interest to many of us here. So please come to that and share your opinions.
So with that, I think we go with the last two ones. We go to the separate side conversations into the list or into the email threads and see where they fit them. And I think we don't have any time for anyone because we are 4 minutes overtime already. I understand.
There's cookies out already, so yeah.
Yeah, the cookies are there in the gathered town, so it's probably go and grab them before other people take them. Okay, so that's all for the Ipsecme, and I hope we had a little bit problem with my scheduling because I was in the vacation when I was supposed to schedule this meeting, so that's why we only get to 1 hour and in wrong location, in overlapping or several other systems. But hopefully that was still useful and so on. Okay, so I think that's it. See you next time in next Ipsecme. Hopefully I will manage to schedule that on time.
Yeah. Okay. Thank you all.